All right, so this is section 1.4. Everything you want to know about lines, all in one section. This is like 3 chapters in Algebra 1, all condensed down to 1. Lucky us. So we're going to calculate and interpret the slope. The most important part is this interpret part. Remember that slope is a rise over run. If you have P be your first point, it's x1, y1. Q is your second point, it's x2, y2. If you got to make sure that your x values are not the same, otherwise your slope is undefined. So here is the slope formula. If you have a highlighter, I would take it out now and highlight it because this guy comes back around. So it's the difference between the y's, y2 minus y1, over the difference between the x's. So that essentially is a mathematical way to represent the rise over the run, the change in vertical over the change in horizontal. If the x values are the same, then the slope is undefined. Since you can't divide by 0, x minus x would be 0. And you cannot have that or zombie apocalypse. Here is a visual interpretation. You take on top, you take the y coordinate from the second point and the y coordinate from the first point and subtract. And do the same thing with the x coordinates. One thing I want you guys to be wary of, and you'll see this more as you get on in your advanced math and your advanced science, is that anytime it's a change, it's this little triangle symbol called delta. So delta y over delta x means change in y over change in x. Mathematicians and scientists are very fond of symbols, especially when we don't have to write the words out. So if you see a delta, you might want to highlight this in your notes so that it's not confusing and freaks you out later. We're going to, as we get more advanced in our mathematics, we're going to be using more Greek symbols. So, all hail to the Greeks. Just kidding. Any 2 distinct points on the line can be used to compute the slope of the line. So if you have 4 points, you know for sure you only have to use 2 of them, and the slope should be the same if they're all on the same line. So it's okay to make some decisions about. Since any 2 distinct points can be used to compute the slope of a line, the average rate of change of a line is always the same number. Just note, it doesn't matter which coordinate goes first. If you're using the second coordinate, the y value has to go first, and its matching x value has to go first. You can use the other point, but it has to be the matching x and y coordinates, or it'll mess up your slope calculation. All right, so let's actually do this. Find the slope of the line containing the points -1, 4, and 2, -3. So we're going to take our y coordinates. This is y2 minus y1 and x2 minus x1. Why did this come out positive? Yeah, because it's minus -1 minus a negative is plus. And we get -7/3. If we do it with the 4 and the -1 first, instead of the other 2, you get the same value. The average rate of change, or the slope, of y with respect to x is -7/3. Compute the slopes of lines L1, L2, L3, and L4 containing the following pairs of points. Graph all 4 lines on the same set of coordinate axes. If you look, all the P's are the same. They're all 2, -3. Or sorry, 2, 3. 2, 3. And the Q values are the ones that change. So if you're calculating the slope, it's y2 minus y1, -2 minus 3, over x2 minus x1, -1 minus 2. And you get -5 over -3. Remember, when you have two negatives being divided, they make your entire answer positive. Slope of line 2 is -1 minus 3 and 3 minus 2. You get -4 over 1. Anything divided by 1 is just itself and ends up being -4. This guy is 3 minus 3 over 5 minus 2. That's 0 over 3. If I have no money and I divide it amongst my 3 friends, we all still have no money. So 0 divided by 3 is 0. And then lastly but not leastly, I get, you can start it out, 5 minus 3 is 2, and 2 minus 2 is 0. But 2 divided by 0 is undefined because we cannot divide by 0. Not allowed. Zombie apocalypse. Okay, so let's look at these lines. So line 1, if I plot these 2 points, I get a nice positive slope. So positive slope, I think of positive as you're burning calories. If I were a little man walking up this hill, I'd be burning my calories, so that's a positive thing when you exercise. The slope 2 is this orange line here. He is negative, and he's really negative, -4, and he's running downhill. Anything downhill is negative. Slope of 0 is a nice horizontal line, nice and flat, like the horizon. And when your slope is undefined, your equation is x equals, and you're straight up and down vertical line. I already said all that, so we can move on. On the same square screen, graph the following equations. All right, so when you put those equations in, y equals 0, y equals -1/4 x, y equals -1/2 x, y equals -x, y equals -2x, and y equals -6x, you get these 6 different lines, and their slopes are negative. So if your little guy is walking on, he is walking downhill on all these lines except for the y equals 0, and the slope for this guy is 0, and he is a flat line, horizontal. Once you have all these graphed, go ahead and take off the negatives for each one and see how that changes the lines. So by changing the slopes from positive to negative, you get all the same, it's got the same level of steepness on each line, but now they're positive. Now if your little guy was walking on each one of them, he'd be walking uphill. And if you notice, they made a little bit of a mistake on this PowerPoint. I guess since I'm distributing the PowerPoint, I'm culpable in their graphing. All right, next concept is graph lines given a point and a slope. So we're going to use the point slope formula. Draw a graph of the line that contains the point 3, 2, and has a slope of 3/4. So if we start at 0.32, the second point on our line is gonna, the y value is gonna increase by 3 to go from 2 to 5, and the x value is gonna increase by 4 to go from 3 to 7. Given the slope -4/5, if we start at 3, 2, I'm going to throw, it could go either way. You could either give the negative to the 4 or the negative to the 5. But in this case, from this drawing, we gave it to the -5. So we are going to go, oh, no, it gave it to the, to the x value. So we're going to go 5 back from our coordinate and 4 up to get the other point and just draw the line through. So when you're doing this on your homework, finding the second point is going to be essential, because you know how you click on the graph and you have to get the 2 points to get the line to display. All right, find the equation of a vertical line. That guy is straight up and down. You will love it. He's pretty easy. When a vertical line is only going to have an x. That's it, just the x. Y is not even going to live there. So x is going to be -2 regardless of what y is. So y could be 4, 2, 0, or 1, and x is still going to be the -2. So x equals -2, the way I graph it is I find x equals -2 on my graph, and then just draw a vertical line. And A is going to be your x-intercept here. Totally easy. Using point slope, form of a line, and identifying horizontal lines. Horizontal lines are the y equals. Okay, so highlight this on your notes. The equation of a line is y. Y stays as y always. You plug in your coordinate, y1, here. The equal sign stays. The slope is calculated. This x value stays. So you always have a y, you're always going to have an x, and you're always going to have an equal sign. This coordinate for y1, the value of your slope, and the x1 are the ones that change. So y minus y1 equals slope times x minus x1. So let's see how we use that. Finding the equation of the line with slope -3 and containing the point. Easy. So if we see y stays, we replace y1 with our coordinate for y. We replace the slope with our given slope. And we replace x1 with -1. And then simplify. Solving for y, we'll get it in our, not standard form, it's actually in slope-intercept form. And this is how we usually like equations of lines to look, where y is on one side and everything else is on the other. The graph of this looks like so. It's got the point -1, 4 right here, and the slope is down 3 over 1. Got this? Let's see this one more time. If I have a horizontal line, my slope automatically is 0. I get y minus -4, because that's our coordinate, equals 0 times x minus our x coordinate 2. This simplifies to y plus 4 equals 0, or y equals -4. If you have a horizontal line and you have a point, you know your end resulting equation is going to equal the y coordinate of that point, horizontal. So the y value stays constant all across your line. You're going to be -4 no matter what your x coordinate is. And that's why we get this equation, where b is your y-intercept for a horizontal line. All right, so now we're going to take away the part where they give us the slope, and we're going to have to calculate the slope because we're given 2 points. So if I have point -1, 4 and 3, -1, I'm going to have to find the equation and graph the line. So I use my handy dandy slope formula, plug in the y's, subtract them, plug in the x's and subtract them. My slope is negative 5/4. I could then use point slope. And we're using our first coordinate, so y minus 4 equals the slope times x minus negative 1. Then we simplify, 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 simplify. And in fact, they are okay with just having it here. I would add 4 to both sides just to have it. And then you plot your 2 points and the line follows. Okay, on step 6. Write the equation of a line in slope-intercept form, which happens to be my favorite. So slope-intercept form, and make sure you highlight this, is y equals mx plus b. M is the slope, b is the y-intercept. All right, so if you look here, each of these equations has an x-intercept of 2. So when you graph those, so y equals 2x, y equals 2, so it's y equals 2. Y equals x plus 2. Y equals negative x plus 2. Y equals 3x plus 2. And y equals negative 3x plus 2. So when you look at your graph, they all come together. They all have a y-intercept of 2. All right, so now let's change those up. 4, when we all have a slope of 2. So what does it look like to have the same slope? So yeah, so they're all going to be parallel. No matter where their intercepts end up lying, when you have the same slope, you're parallel. Okay. Alright, so identifying the slope and y-intercept from the line, all we have to do is solve for y, and the slope and the y-intercept fall out of that equation. So if I have 3x minus 2y equals 6, I want to solve for y. So I'm going to subtract 3x from both sides to get minus 3x plus 6. Next, I want to divide everything by negative 2. So this is going to get divided by negative 2. This is going to get divided by negative 2. And I get y equals 3/2 x minus 3. So I know my slope is 3/2, and I know my y-intercept is negative 3. So on my graph, I plot the point negative 3, or 0, negative 3, and I go up 3 over 2. Boom. And I have my line. Boom. All right, graphing lines using the general form. So this is where it gets crazy. So when you have x and y on the same side and all of your constants on the right-hand side, that is the general form. So if I get that same similar equation in general form, you can find the x and y intercepts. We find the x-intercepts by setting y equal to 0. So we know that 2, 0 is a point on our graph. And then we do the same thing. We find the y-intercept by setting x equal to 0. So we know 0, 3 is another point on the graph. Click those 2 points, and you have your line. Equations of parallel lines. We found out that the parallel lines have the same slope. They have different intercepts but same slope. So if you know that the 2 lines are parallel, you can steal the slope from the other line and find the equation of your parallel line. We're going to show that these lines are parallel. So we're going to do that by solving for y. And we know that the slope is 3/2. We're going to solve for y here, and the slope is 3/2. All you have to do is show that the slopes are the same, and the lines are parallel. Find an equation for the line that contains the point -1, 3, and is parallel to this line. So I'm going to solve for y. Now I'm going to steal this slope. And I'm going to use the point slope equation. I know that the slope is going to be 3/4. And I'm going to plug in 3 for y and -1 for x. Add 3 to, simplify this down and add 3 to both sides to solve for y. And you have the answer. Equations of perpendicular lines. Remember, this is an entire chapter. Perpendicular lines, when you multiply their slopes together, you get -1. So the product of their slopes is -1. Highlight this. So perpendicular, product of their slopes is -1. We also say that their slopes are negative reciprocals of each other. So when I want to find the slope of a line perpendicular to the line with slope 3, 4, I take 3/4 and I flip it, so now it's 4/3, and I change the sign. It was positive here and now it's negative here. And it says I get to, it only wants to find the slope, so we are done. Just for the record, perpendicular means 90 degrees. And find an equation for the line that contains point -1, 3 and is perpendicular to the line 3x minus 4y equals 12. So we're going to solve for y. Now I know the slope is 3/4. We're going to flip it and change the sign. So it's going to be -4/3. Then we're going to plug it into our equation right here for m. We're going to plug 3 in for y1, -1 for x1. And we get the equation. Simplify it out. Add 3 to both sides. Got this. Perpendicular lines. And that's all for today's 1.1.